Okay, so this video is about ASCII, which is the way that we take letters and represent them on computers. So it says below is printed the standard ASCII table for printable characters. The characters with codes 0 through 31 are not printable, so there's other types of things that are before here on the table. Also the extended ASCII table with codes 128 to 255 representing special characters such as the upside down question mark is not shown. So we're going to use exactly 8 binary digits for each letter, and we're going to express this word. So I'm actually going to change the word to one that I did earlier. I tried to make a video at home and my Chromebook was being too slow. So I'm going to do the word just. Okay. So looking here, I find the J, capital J, and next to it is the letter 70 or the number 74. And then my U, S, and T are really close to each other. So just scroll down a little bit. So here's my U, S, and T. So the letter U is 117, S is 115, and T is 116. So it says that we have to use exactly 1 byte or 8 binary digits, right, which equals 1 byte for each letter. And the reason for that is we need to be consistent. So even though we really only need 7 digits, we need to let the computer know that these 8 represent one number, and then the next 8 represent another number or letter, and so on. So for the J, I'm going to put down my 8 digits. Okay, and I'm going to write down the place values. So we know this is how we number the place values, right, because it's powers of 2. So in the number 74, I don't need a 128, right? I do have a 64, so I'm going to subtract that and get 10. So since I have 10, I don't need a 32 or a 16, I need an 8. And I also, you can probably just do this in your head, but I'm going to write down the word for it. I don't need a 4, I need a 2, right? And then it's gone, and I don't need a 1. So this is our first byte, and this is the letter J. So that would be the first thing that was entered for the word just. So for U, so for all of these letters, the capitals and the lowercase letters and the numbers, if we look at this table only goes up to 127. So we're actually always going to have a 0 here unless we were doing one of those special characters. So for the 117, which I'm going to write on the side here, I have a 64. I have a 32. Basically, a 32 fits into what's left is what I'm using for this. I have a 16. I don't have an 8, and then I do have a 4, minus 4, no 2, and a 1. Okay, so that's my number for the letter U. Okay, now the nice thing is, since S and T are so close to that, I know that S is going to start out the same way, okay, and it's just going to kind of be different at the end when I get to that end section. So I'm going to do the 115. I'm actually going to erase this 117. Okay, put that on the side. So we have a 64. We have a 32. We have a 16. Oops. And we don't have an 8 or a 4, but we do have a 2 and a 1. Okay, so basically when I look at this, I'm just going to fill back in what was up here. This was a 1. Okay, here is my U number. Here is my S number. If you look at the end of these two, I ended this one with a number 3, right? A 2 and a 1. I ended this one with a number 5, and that's the only difference. And the U is 2 bigger in terms of its number than the S. Okay, so for the T, basically I can use 1 smaller than the U So it's going to start out, and if you need to do each of them from scratch, that's totally fine. I ended this one with 5, so I'm going to end this one. Skip to 1 there. Okay, so 0, 1, 1, 1, 0. So I'm going to end this one with 4, which is 1, 0, 0 at the end. So on the delta math, okay, this looks like a ton, but basically I would type in a row these 32 digits. So 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, and so on through those 32 numbers. Okay, now this seems excessive, right? But this is what the computer needs to do. This is basically, it needs those 32 microchips just to represent the word just. Okay, so you can start to see how stuff builds up as we go along. So down here for the questions, this is where I would type those digits, which takes blank bits and blank bytes to store inside of a computer. Okay, so here, each of these letters, the S and the T, is 1 byte. It's 8 bits. So we take 4 total bytes because we have 4 letters. 4 times 8 is 32 bits. Okay, so you type in all those digits together and then put that in, and that would be your final answer. And just a final note, when you do this, you can start to see everything that you represent on a computer, whether it's a picture or a video, color, text, graphics, anything, sound, all needs to be broken down to these zeros and ones and thought of a way to represent it. Okay, so this is an easy one. Sound, right? Videos take a lot more bits, but you get the basic idea.